Hello friends, in this video, let's have a look at problem 2616, minimize the maximum difference of pairs. In this video, we're going to explain a treatment based on binary search. First, let's look at the problem statement. So here, we are given a zero-indexed integer array called nums and integer p. We want to find p pairs of indices of nums such that the maximum difference among all the pairs is minimized. So also, we ensure no index appears more than once among the p pairs. So here, the distance is in the sense of absolute value and difference, the absolute value of their difference of the elements, right? So we are required to return the minimum possible maximum difference among all the p pairs. So we define the maximum of an empty set to be 0, right? So here are two examples. In the first example, the output is 1. So you can digest the explanation here. And in example 2, the output is 0. So this is easy to interpret because we have 2 and 2, right? The same number, but appears at two different indices. And p is also 1, right? So the additional constraints are the following. First, the length of this list nums can be up to 10 to the power 5. So 10 to the power 5 actually is a decent large number. And the elements in the list is bounded below by 0, in other words, non-negative, and bounded above by a large constant, say 10 to the power 9. So thirdly, so p is bounded below by 0 and bounded above by the length of the list divided by 2, right? So because p is integer, so we can understand this as an integer division. The effect will be the same. So with that said, we are ready to look at our procedure. So here the treatment is based on binary search. So the first observation is that we can sort the list nums so that for a fixed index I, so we are going to have the nearer the later indexed to I, the smaller the difference, the absolute difference, right? Also, we know that after we sort, if the index is larger and the number, the corresponding number is also larger, or at least equal, right? So the idea is that we're going to transform the problem to be that we're going to find the mean of the max difference such that we can find at least p pairs of distinct indices pairs such that the corresponding elements difference all less than or equal to the max difference, right? So then if we realize this idea, actually the coding part is very straightforward. But the main thing here is if we can digest or grasp the main thought. So here is some mathematical reasoning hidden here. So here let's look at the algorithm or steps. So this is actually very routine now. We have a list in explaining or demonstrating the usage of binary search. So you are welcome to follow up there. So here step 0 is that we sort the list nums. This one, the purpose is to be sort of greedy because we know that two nearby elements have a smaller gap or distance. Step 1 is we write a utility function. I will call this utility function fulfill. It accepts a max diff as argument. Basically, we want to check for a given max diff if we could find p pairs of distinct indices such that their max difference is bounded above by this max difference, right? Then step 2 is to find the smallest possible max diff such that this function is true, right? So this function is a Boolean function. Step 3 is to return the max diff in step 2. With that done, basically we can look at code first and then we make some comments. So we are going to follow the above step in a faithful way. So first we are going to call preparation. So we are going to sort this nums list And then for convenience, I'm going to retrieve the length of this nums. So this is step 0. Step 1 will be a Boolean function to produce order or monotonicity. So here, as we mentioned, so we're going to define a function called fulfill. So basically, it accepts a max diff. So this is the integer. So here, let's use some type hint. So we're going to return a not a int. So here is Boolean, right? So what we want to do. So let me just maybe delete that. So what we want to do is to check. So here, if we could find p distinct index pairs such that their differences or gaps is bounded above by this max diff, right? So now let's write the function. So here, let's count the pairs. Let's define this as 0. So we just check if we can find p pairs, or at least p pairs. See. So then originally we can start from index 1 because we can check the first index and the current one, right? So while I is less than n, right? So we're going to check this one, nums I minus nums I minus 1, because we start I from 1, so I minus 1 is non-negative. In other words, it's a valid index. So if I is 0, nums negative 1 will be the tail element in nums. This is not what we want, right? So if this one is less than or is bounded by this max diff, then we're going to count pairs increment by 1. In other words, we include the current I. And then we're going to increment I by 2, right? We look at the next pair, then we compare, we consider I minus 1 again, right? So this is the one case. In the else block, what we are going to do, if this is too large, the gap, right? Then we're going to start from next. So we're going to increment I by 1, right? So we're going to look at the third one element and the elements just before it to check the gap, right? So in between, I would also like to add a early stop condition. So if count pairs is greater than or equal to p, then we are done, right? We can find p pairs, so we're going to return true. So afterwards, if we exit this while loop, still we haven't returned anything, we're going to return false, right? In other words, we cannot find p pairs. So this is the main work, one of the main work. So next, we are going to do binary search. So for this part, basically, we want to properly doing several things. First is a search range, right? And the second one is shrinkage. How do we do shrinkage? There can be some variations, right? And also do the return. So for this problem, the low and the high, the lowest gap or possibility is 0, right? Because this the gap is the absolute value is at least non-negative. And then the largest gap will be max of nums. So basically nums negative 1, right? Because we have already sorted it, right? Then minus nums 0. So this will be the max gap. I will call it high. And then we're going to do the the while loop. So while low less than high. So now let's look at our shrinkage. So because this one, we're going to do what we are going to do here is find min max diff such that the fulfill max diff is true, right? So this is what we want to find. So because this is the minimization problem, I want to start from low, then move 1/2 up, right? So this will be low plus high minus low interdivision by 2, right? So if the list is longer enough and the the max diff is large enough, so you can estimate very large, then this value will be true, right? That's why we want to find the minimal gap using this format. So now let's check, right? So if fulfill, if this is true, so in other words, for the current mate, this returns as true, then we're going to set high to be mate, right? Otherwise, so this fulfill mate is not true. In other words, mate is too small, so we're going to make low equals a mate plus 1. So notice that in the above pattern, so the high is always making this fulfill true, right? So we're going to return high. This is our return. So now this code forms a solution format to this specific problem. So now let's look at a test case. Yeah, it passes one test case. Now let's look at the generic case. Yeah, it passes all the test cases. So now I think it's good to make some comments here. First is that the Boolean function in step 1 is used to produce order or monotonicity, right? So the design of this function shall take into consideration of the problem logic. So basically, it's problem subject, right? The second one is that for the binary search, we need to identify the search range and do proper shrinkage. So we can think of shrink half from high to low or from low to high. And also we need to do proper return. And the third one is that if one prefers to use the bisect module, say in Python, so now we could input a key to the bisect left or bisect right methods. So if you modify this code here, so you could also write another format solution by directly using bisect left method. So I will not specify that code here, but you can have a try. So with that said, basically that's about it for this problem. Let me give a quick summary. So in this format of solution, we divided into 3 steps. So one step is to make some preparation. Here we are doing sorting mainly. And then in the second step, we wrote a Boolean function, right? And the third step, we do binary search. So we specify the search range, and then do the shrinkage, and then do the return. So with that said, I guess that's about it for this video. Thank you.